In this short video, we would like to show you how to use JobShop. The program allows detailed planning in production and services. It is called Advanced Planning and Scheduling. Advanced planning, which is extended to detailed planning, has many advantages. First of all, it saves time, approximately from 10 to 30%, helps setting realistic deadlines, creates better production organization, optimizes logistic processes, and generally increases the transparency of processes. The program works with imported data from other information systems. After creating a detailed plan, we usually export the result to the other information system. First, we specify the start of planning with a day and an hour. Notice the list of workplaces or a list of machines on the left. This program displays machines or workplaces in the order of priority or preference. If it is not specified, the program automatically calculates the preference based on the number of jobs waiting for the workplace. Practically, this means that the first machine on the list will be the one with the most jobs and the last one with the least jobs. At the same time, we see a calendar where gray bars indicate that the workplace is inactive. In this case, we see that all machines are set to 3 shifts, except of one machine, and they do not work on Saturdays or Sundays. These are the gray lines. However, this machine only works 2 shifts, which practically means that it starts work at 6 a.m. and ends at 10 p.m. Let's look at the imported data now. The imported data contains so-called sequences, which are tasks or operations in a linear order. These operations will be performed according to the specified technological procedure on specific machines or workplaces. In this one job program, a job can contain more sequences, even a whole network of sequences, which we will show later. Here, one color is related to one job and you can change it. Each job is automatically evaluated according to its labor intensity, and at the same time we can give preference to each job. These two numbers constitute so-called dominance, which the program uses at planning. As we see, the preference coefficient is 0.5. It means the labor intensity and preference is represented in a ratio of 50 to 50% in dominance. Now we start planning individual jobs or sequences. First of all, we plan 2 tasks to see what actually happens. So here we see one blue and one red job and their operations. If you click on an operation, a line will appear on the top, which will show you how the whole job will run. What else can we see? This small line shows the time required to set up the machine. In this particular case, it is 53 minutes. The length of the line means the time of realization. And finally, there is one more time, which is the time of realization and transport. In this particular case, there is no transport. But here, you can see transport, and it is this short line displayed as a dashed line. We can move any operation, and because the program registered all changes, we can also revert the changes. Now we'll schedule more tasks. In this case, we can see that this task began on Friday and continues till Monday, and these gray lines indicate that the machine did not work during the weekend. If these lines are troublesome, you have the option to skip their display. To do this, we must first save the existing plan. We name it and then we save it. Afterwards, we set the filter. We don't explain the filter in detail, but it means it should show all days except Saturday, Sunday, and holidays. The program has displayed a new calendar, and now we reload the saved data and see that Saturday and Sunday have disappeared. The red line indicates that the view is incomplete. Therefore, we reduce the size of the screen to see the whole process. The created program of the plan is not optimal. In reality, it is challenging to make an optimal plan because the term optimal means something else for different types of production. However, this program gives the possibility to adapt the production plan to our needs easily. Now, we'll show you how to change your plan. We can see that this task started late, and that is why it stands uglily at the end of the plan. Although there are unused sections that could be filled, let's look at what it would mean. Let us take this task as a blue task. This icon is used for this purpose. Select the task you want to move, press the icon, and select the task for which you want to move it. Well, the program did it. But there is one problem. This workplace has one capacity. It means that it can only perform one task at a time. But as we can see here, we should perform two tasks in parallel. Here, we have the so-called one conflict. To do this, we will use the conflict solution icon. The program has done this and has shifted the other tasks. Let's see how it looks like. We see that it would be a good idea to move after these tasks. These arrows serve for this purpose. We move them without conflict from left to right. What else could we optimize here? It should be mentioned that this machine is the most important because it has the most tasks. We see a gap here that should be removed. Let's look at what we can do. So let's move this blue task after purple. We will remove conflicts and move the task from left to right. Now we move the red task after the blue one. We will remove conflict and move the task from the left to right. And now we move this violet as close as possible. This plan can already be considered as good for machines. But in terms of utilizing human capacities, this may not be true. we create one new group of machines, which we name all. We put all the machines in this group and say that these machines can be set up by 6 people. Here we see a chart showing how many people are needed to implement the plan. As we can see from the chart, we would need 11 people at the beginning, so we would not be able to implement this plan with 6 people. So let's try to optimize for human capacity. Gradually, we'll go through each of them and see what can be moved. In this case, the situation is more complicated. This job contains up to 3 sequences: green, blue, and red. For example, they produce product A on the green sequence, product B on the blue, and as the AB product continue on the red path where, for example, they fold, paint, wrap, or so on. So now we have 2 roads. We choose the green one and say we move the operation here. Meanwhile, the graphic is changing. Let's move on. This is great. This is great. Now we have just managed to create a plan for 6 people, but of course we can continue with this. Now we'll store it in a database and see what we got. We see that it is time for each machine, so we know what they do, when they start, when they end their job, what job it is, what is name of job, the sequences are given, and the amount is given. Now we select one machine and export the data to both HTML and Excel. This is how it can be printed and let people see that each operations run according to this schedule. So this is everything we wanted to show you. If you would like to know more, click on jobshop.72.sk. Thank you.